I'm going to do another example of a custom node. This time I will copy code from an Arduino example. I have a MEMSIC 2-axis accelerometer. I found this page on the Arduino site with wiring instructions and example code. I wire up my hardware as seen in the diagram. Then, to make sure the hardware works and is set up correctly, I copy the example code into the Arduino IDE and upload it. Once it uploads, I open up a serial monitor and wiggle my breadboard around and see that I'm getting back data. In Embrio, I again create a new empty node definition and drag it onto a node screen. I open it for editing and rename it accelerometer. Because this node will read from Arduino pins, I check the touches physical pin checkbox. At this point, let's inspect the Arduino code. The code has two constant variables to set the pins that the accelerometer is plugged into. I want to be able to reuse this node, and I don't want to have to edit the code when my pins change. So instead, I will add two integer inputs and rename them X pin and Y pin. The default range for an integer input is 100, but there aren't that many pins on the Arduino, so I will change the default to 20 for both. The loop code in the Arduino example is sending the acceleration data back via the serial port for display. I don't want to do this. Instead, I want the acceleration values to be sent to the node outputs. Most values in Embrio are dealt with as an activation, which is a floating point number between 0 and 1. I add two activation outputs and rename them acceleration X and acceleration Y. The acceleration data can be negative, so for both outputs I click the minus sign to include the negative range. The node's inputs and outputs are set up now. Back in the setup block in the Arduino code, I will ignore the serial begin line because this node won't be using the serial port. Nodes should generally not use the serial port. Instead, they should be setting their output values. Because we are configuring our pins with inputs, the values can change while the program is running. So we won't be copying this code into our setup block. Instead, I will create a new onChange event, select both inputs, and paste the code. We don't have an X pin or Y pin variable, so I replace that code with input underscore X pin and input underscore Y pin. Now I will copy the loop code. I select everything in the loop block up until the serial.print calls. Also note that this block has a delay, which we definitely don't want. Embrio nodes should never call delay. All timing in an Embrio program should be done by Embrio itself. I want this code to fire on every update, so I select the every update event and paste in the code. Again, we don't have an X pin or Y pin variable, so I replace those with input underscore X pin and input underscore Y pin. Note that this code uses the pulse in function. The pulse in function has an important overload when it comes to Embrio. By default, this function will wait until it receives a pulse. This could take a long time. If this ends up taking a long time to return, it will cause problems in your compiled Embrio program. Because of this, we want to pass the optional timeout value. This is the number of microseconds to wait before returning. I will let it wait for 15 milliseconds in a worst case scenario, so I add 15,000 for this value on both lines. This code results in an acceleration value in X and Y as integers between about -1000 and 1000. These values aren't very useful for Embrio. We want to transform them to the range of an activation and update the node's outputs. To do this, I use the built-in transform function. I write output acceleration equals transform, open parenthesis, acceleration X, comma, -1000, comma, 1000, comma, -1, comma, 1, close parenthesis. This will scale the acceleration value from the range of -1000 to 1000 to the range of -1 to 1 and assign it to the output activation. I do the same for the Y value. Finally, I close the node, which saves the changes, then I connect to my Arduino. After the program uploads, I wiggle my breadboard around and see the values update, and I open the output graphs to get a better view of my data. If you have a full Embrio license, you have access to the resource profiler. I'm going to go to the resource tab. Because I don't yet have any timing data for my new node, it shows up in the timeline as an empty placeholder, and in the details tab shows that the node is untimed. I click the Run Timing on Arduino button. The timing program is uploaded to the Arduino, where the code is executed and timed, and the timing data is sent back to Embrio. When I receive this data, I can see that the accelerometer node takes almost 20 milliseconds to run. This is a lot of time considering that there are only 1000 milliseconds in a second. The agent that the node is running on updates 32 times per second. So out of every 1000 millisecond program loop, the accelerometer is taking up almost 600 milliseconds. If I change the refresh rate to 64, now this node is taking up over 100% of the time the program has to run per second, so this program will not run in real time. This is good information to know. Depending on your situation, you want to use the lowest refresh rate that you can for this node to reduce how much of the time resource it requires.